All right, so this is when we are going to start getting into assemblies. This is a really important part of CAD, knowing how to assemble components together, because from there we can create simulations or we can test out our parts. We can move them around, see how everything fits together. It's really that first step when it comes to like prototyping, seeing how our components are going to function together. And that's why assemblies are really important. There's three different types of assemblies that we're going to look at. This first one is bottom up. So in this scenario, we have all of our components already created, and we need to assemble them together in one file. So we already have everything done, everything has been modeled, and we are just going to be bringing in the individual components and assembling them. So for this assignment, we are going to be creating this 4-way 2-position directional control valve. So this control valve has a handle, and when we pull that handle or push it, it's going to change the direction of the valve. So we have already all these components already modeled. We just need to assemble them together. It's really important here that we keep our file structure correct. So all the components and the assembly file itself need to be in the same folder. So we want to create a folder for each of our projects. Sometimes we'll have one where it's not even, we don't even have an assembly, but we might have that part drawing where we're using the master model approach. We want those two to be in the same folder. Also, if you were to send, let's say that we had an assignment and I asked you to send me any assembly that you wanted, you would have the components, individual components, and then you would also have the assembly file. If you just send me the assembly file without the components and I try to open up that file, I will not be able to because I don't have any of the individual components. You have to send everything that is part of that assembly file, every component that is used, otherwise it's not going to open up. For this assignment, we are going to create the assembly, and all you're going to submit is the assembly file itself. I have all the components already. So when I open up your assembly file, I will already have all the components that you used to create it. So for this assignment, just submit the assembly file that we create. So there's a list of steps here. The umvalvebank.zip, that is where all the components are at. So download this, and then there's a file in this zip folder that is the umvalvebank folder. Extract that folder and put it on your desktop, and that is where we are going to create the assembly file. So let's go ahead and get started. So we can open up NX. Again, make sure that you are in the advanced role. We are going to go to new, and we're going to create a separate assembly file from the components that are in that valve bank. So we go to model, we can create an assembly. We're going to name this homework 11, and the location that I'm going to store this in is in that umvalve bank folder. So mine is right here. You got blank models, and that's where I want to store it in. So this is where all the models are at. So I'm going to save it in that same location. So now I can hit OK. When we first create an assembly file, you'll see this window pop up. We can continue using this, but I'm just going to exit out. And I want to point out one thing. So we create an assembly. Typically, we create a model. With this time, we created an assembly. But look at the file name. So we've got homework 11 UUID. It's still a .prt. The file is not different. It's still a part file. It's just a different application of NX. So we can go to assemblies, and this is where we are able to bring our parts into this file. What we want to do is we can add component. We can add a component. And this dialog window, this box pops up. This is similar to what first popped up when we created the assembly, a little bit different. What we want to do is go to the folder that we want to open. And because we saved it into this folder, these are all the files that are available to us right now. So the first thing that we want to bring in is the block. So I'm just going to click on the block and I'm going to hit OK. And nothing really happened, right? We've selected the part, but we can't really see it anywhere. So what we want to do is we want to come down and select object. And now we have some location things that we can change. So we can change what coordinate system we are referencing. We can snap. So the snap is where we can actually move it around and just click wherever we want to actually put it. But we can reference the absolute work coordinate system, and we can change it. We can also change it along the WCS. And so we can go to, so let's go to the absolute coordinate system. And we want to come down to placement. And this is how we are able to just move it around because we have move selected. If we click on constraint, we can start to constrain this, this part. The assembly constraints are similar to the constraints that we've seen before with our sketches, where we have done coincident or horizontal, vertical. It's similar to those, but with the assembly constraints, we are constraining solid body objects in a certain way. So we've got a lot to choose from here, but the first part that we put in, we typically want to use a fixed constraint. What the fixed constraint is going to do is it's going to fix it in space. We won't be able to move it around. That way, whenever we create a constraint that allows movement later on, we aren't moving around the block accidentally. So we want to actually use a fixed constraint here. It's asking us to select the object. We can hit apply. And we should see, yeah, we've got a fixed constraint right there. Now, let's look over at our part navigator because we have another tabs that we can look at. So we've got the assembly navigator. The assembly navigator is going to show us all the components that are placed into our assembly. And if we break down the constraints, we can see what constraint is being used as well. We also have the constraint navigator, where we can view it by constraint. So this will be labeled by all the constraints that we have. We can see which item or which solid body is being used with that constraint. So we have put in the block and we've put a fixed constraint. Now we want to add another component to this. And so we want to come back up to add component. Want to select our part, again, hit our folder. And we want to go ahead and select our spool. So select the spool, hit OK. And there is our spool. So we have still the same options that we selected before on the screen. But we're not going to constrain this like we did with the box. What we want is to go back to snap, change this to move, and we're just going to click somewhere off of the box. And so since I selected move, I'll be able to position this. And I just like to sort of position it kind of in the way that it's going to be. So this spool is going to be going through this center hole. So I'm going to rotate this 90 degrees. And I'll go ahead and move this over a little bit. And that's close enough. I'll hit OK. Doesn't have to be perfect, and really don't have to do that if you don't want to. I just find that it's easier to move objects that are closer together. So we want this spool to be going through this center axis here. And then we also want this hole to be perpendicular to the hole. So we want it to be parallel with this surface on this side of the block. So the first thing that we want to do is we want to add a constraint that aligns this circle with the the circle of this part. And you can see how choppy these features are. Not really a round hole. We can fix that. If you right click on the part and you say show exact, it will change that to the actual geometry of the part rather than it being a little less quality. So we're going to add a constraint to align the axis of this part with the axis of this circle. And in the Assemblies tab, we have the position. We're going to go to Assembly Constraints. That's going to bring up our constraints that we have available to us. There's a couple ways that we can do this. We're going to stay in touch align. For the orientation, what we want to do is we want to infer center axis. With infer center axis, we select two axes, and it's sort of like a collinear, so they're going to be on the same axis. Now it's not going to move, it's going to move the spool down to the box because this box is fixed, it cannot move. So we can select the actual axis, which would be this center line, or we can just select either the circle, like the line right there, or this inside face. It's going to automatically select the axis that is in the center of that shape. And we come down here and do the same thing for the inside of that box. Now we can hit OK. And if we click on the spool and we go to move, the spool can now move in and out. But if I try to move this up, it won't move. It has to be on the same axis as the that hole that's going through the block. If I try to rotate this, I can still rotate it. So it's still on that same axis, but it allows for rotation. What I want is for this to be constrained so that these holes run parallel with these holes here. And the way that I'll do that is I'll go back to my assembly constraints and I'll do a parallel. If I get to select two objects, I'll select this inside face, and then I'll select the outside face of this block, which means that this plane and this plane will always be parallel to each other. So if I go back and try to move this block or this spool, if I try to rotate this, I can no longer rotate it because it has to be parallel. This face has to be parallel with this face. But I can still move this spool in and out, which is what I want. I want that spool to be able to move in and out. And I'm gonna go ahead and kind of position it where it's supposed to be. And I'll hit OK. Now we need to add another component, and we're just going to keep on assembling these components together. So go back up to Add Component. Hit the folder to open. And what we'll do next is the end plate. So we'll click on the end plate, hit OK. Select the object, and we want to be able to just move this around. We're going to do it similarly to what we did with the spool. So I'm just going to click over here somewhere. Now this back plate is going to be positioned along this face here. So I'm going to rotate this. And then rotate it again. Again, this is not necessary. This is just what I like to do. And I'll just bring this over. And that should be good. I'll hit OK. And so we want to line this up so that it's on the back of this plate. These holes here are where the screws are going to be going. Imagine that these are threaded holes, and we will attach this back plate with some screws. So we're going to add some constraints. So we could do the infer center axis again, but let's do concentric. So concentric constrains two circular or elliptical edges so the centers are coincident and the planes of the edges are coplanar. So it's going to align the point and the same plane. So I'll choose coincident. And what I'm going to choose is the edge of this circle here. And I want to select the edge of this inside circle. So that does two things for us. That aligns it so that it's on the same plane. So this back plane and then the back plane of the plate. And also makes it concentric. So I'll hit OK. And I'll go ahead and also change this so that it shows those exact circles. So if I try to move this now, if I try to move it left and right, I'm not going to be able to, or up and down, I'm not going to be able to, because this hole and the hole through the center of the block are concentric. And then I also am not going to be able to pull this off of the back plate because I used that assembly constraint. I will not be able to, they will be on the same plane as well. I will, however, still be able to rotate this. If I try to rotate this, I can still rotate this part, and I don't want to be able to. So to stop this from rotating, what I'll do is I will create a parallel constraint from the top edge of this part to the top of the block. I'll come to assembly constraint, and I'll do another parallel, and I'll choose the face of the block and then of the plate, and I'll say OK. Now if I try to move this, let's try to rotate it. It won't let me rotate it. and I won't be able to move it back and forth or in and out. We have correctly constrained this component. All right, we're going to add another component to our assembly. On our folder, this will be the fulcrum. And we'll select object, and we will simply move it over here. And this will be on this face. Hit OK. I'll go ahead and show the exact. And so these 4 holes line up with these 4 holes. And then this is where the big hole is where the spool is going to be moving in and out. So I'm going to, similar to how we did the back plane, I'll do a concentric with this circle and the inside of the spool, or the inside of the block. And so sometimes with assemblies, it kind of gets a little bit difficult to see what you need to with other parts in the way. So what I'm going to do is I'm actually going to hide this spool. So I'm just going to come over here to our assembly navigator. This is where we get to see all of our parts that are in our assembly. And again, we can see all of our constraints. If we go to our constraint navigator, we can see which ones have the concentric, which ones are using parallel. These are filtered through by the constraint type. Our assembly navigator, we get to see all the parts, and this is where I want to hide the spool. So I'm just going to uncheck that box. So the spool is still there, I just can't see it. So I'll go to assembly constraints. Again, I want to go to the concentric constraint. I'm going to choose the back circle of the plate, and then this front circle of the block. I'll hit OK. We can go and get that spool back in. And now, just like with the back plate, I won't be able to move it in or out, over, side by side, anything like that. But I will still be able to rotate this, and that's what we want to constrain next. And we'll do something similar, except if you look at this over on the end plate, we said that this top surface was parallel with the surface of the block, but we don't have a flat surface over here. This is tapered. But we're going to do something similar. It's just that instead of defining this by the face, we can just define it by a line. So we'll still do parallel, and I want to choose the edge, and then I will do the face of the block. Hit OK. And now if I try to move this, can't rotate it, can't move it in, can't move it out. This has been correctly constrained. Add another component. And we are going to add the operating lever. Select component, and we just put it over here. And this is going to be positioned along these 2 holes. So I'm going to rotate this. And that's good enough. We'll go ahead and show the exact on this. And this is going to rotate around this hole, which is positioned in the fulcrum. And so as you move this lever forward, it pulls this spool out. And as you pull on the lever, it pushes the spool in. That's how we're changing which valve is being selected. So let's go ahead and position that operating lever to rotate around this axis. So ideally, we would have a sort of pin here that would allow for the operating lever to rotate around. We don't super need it. So what we're going to do is we're going to act like we do. And so it's going to be on the same axis as these two holes. And we don't want to do a concentric. What we want to do is go back to the infer center axis. And we want to select the inside hole here. And then the inside of just one of these, either this one or this one. Does not matter which one we select. We can hit apply. See, now it's on the correct axis, but it's not positioned correctly. So this can move along that axis, move axially, but it cannot move away from that axis, but it can still rotate along that axis, which is what we want. But we want this to be positioned in the center of this fulcrum right here. And so we can add another constraint. And we want to do center. The center, we have some options. So if we go to subtype, so we've got a 1 to 2, a 2 to 1, or a 2 to 2. We're going to select the 2 to 2. So on the operating lever, I will choose this face and this face. And then I'm going to select the two faces on the spool. I'll choose this face and that face, and I'll hit OK. And so now this lever will be able to rotate as it's supposed to. And what we need is a way to connect the operating lever to the spool so that when we do move it, the spool is moving as well. Now, ideally, we'd have a pin in the spool, and as we move the lever, the edge pulls or pushes on that pin, thus pulling or pushing the spool. But we don't actually have to have the pin in this setup to do this. We can do it just using the assembly constraints. And so what we want to do is we want to go back to our assembly constraints. We want to go to the touch align, and we want to choose an align. We don't want to do the center axis. We want to choose an align. And I'm going to choose this inside face of the lever and one of the holes. That's going to means that the surface here is going to be aligned. That's aligned. And that's going to say stay aligned as we rotate. We can hit OK. And now if I rotate this handle, so I'm going to move. I'm actually going to click on that, and I'm going to change the snap so that every time we move, it only increments half a degree. And I'm going to rotate this around. Now as we rotate this, or as we move the handle, we are also moving that spool. A couple other things that we need to add. We need to add another component. We are going to add the knob. And the knob is going to go on the top of the lever. Okay. We want the hole here to be on the same axis as the knob. So we'll go to the touch align constraint, and we want the infer center axis, and I'll select the inside of that hole, and I'm just going to select the shaft of the lever, and I can hit OK, and then I'm going to move this so it's positioned a little bit better, about right there. And what we want is from this bottom edge of the knob to the top of the operating lever to be 1/2 inch. So we go to our assembly constraint. We can go to a distance. There it is. We can go to distance, and I will select the face, and I will select the face of the operating lever. If it's hard to get that to highlight, remember, if you wait for the 3 dots to appear and then click, you can better select what you're trying to get to. So we want the face of the operating lever, and we want that to be 1/2 inch, 0.5. Make sure that you get that right from the bottom of the knob to the top of the lever. Now when I move this, rotate the knob, I'm rotating the lever, and then I'm also rotating the spool. So these components are all connected together and moving in the way that ideally they would in the real world. And this is a great way to test your parts before you actually even prototype them, before you 3D print them or do whatever you need to do to prototype them. This is the first visual check of whether these are going to work together or not. And we need to do one more thing here. We have add another component, and we have these O-rings. So these O-rings go in these grooves of the spool. And so we need to position each of these O-rings onto our spool. So to make this easier, I'm going to hide the block, and then I'm also going to hide the fulcrum. So we need 1, 2, 3, 4, 5 of these O-rings. I need to be able to put these O-rings on so that they are on the same axis as the spool, and then also in each of these slots. I can do the axis of the spool pretty easily. We just go to assembly constraint, do infer center axis, select the center axis of the O-ring, and then just select any of these surfaces that are on the spool. It's going to position them on that same axis. But to get them to be where they need to line up is going to be a bit difficult, because I don't really have many things to choose from. So if I go to O-ring, and I go to replace reference set, and I go to entire part, you can see the datum plane that was used when making the O-ring. And so we can show this construction geometry that was used to create the model. We can show that in the assembly as well, and that's helpful for when we actually need to reference that in the assembly too, because this is going to make our life a lot easier. So if we go to assembly constraint, and we want to do another one of the centers, but this time we're going to do a 1 to 2. And I'm going to select that plane. So I'm selecting one object, and that's going to be in the center of 2 faces that I select. So I'll select this face of the spool and then this face of the spool. And now it has been constrained so that it is in the center of those two faces. And that has been constrained correctly. Now I need to add 4 more of these O-rings. A little trick, if you need to add a component that's already in the assembly, if you click on the component and just click add component, it's going to automatically select that component and add another one. We can also change the count. So we can change the amount that are put into the model. I needed 4 more. There's the 4 other ones. And now I can start adding my constraints. You can change that reference set back to model if you want to. You can show all of the components again. So just like when we hid all of our sketches and datum planes and everything else, we can hide our constraints here to kind of give us a better display of what's going on. So again, we're going to go to View, going to select Move to Layer. On our filters, we can select Assembly Constraint. We can select All, and we can hit OK. We can just throw these on the datums layer and hit OK. If we go to the layer settings, turn off that layer, and our constraints are gone. But I think that's all that I got for this one. So thanks for watching.